Hello friends, now we'll start the miscellaneous exercise for the differentiation. Now let us start. Select the appropriate answer from the given alternatives. If y is equals to x minus 4 upon in root of x plus 2, then dy by dx 1 upon x plus 4 b root x upon root of x plus 2 bracket square 1 upon 2 root x, and d is x upon root x plus 2 bracket square. Now here we will find out the answer. Then y is equals to u upon v. Now here we apply the quotient rule. dy by dx is equals to v into du by dx minus u into dv by dx upon v square. Here u is x minus 4 and v is a root of x plus 2. Therefore dy by dx is equals to root x plus 2 into ddx of x minus 4. This must be the bracket square. I forget to write it. See this here. That is a root x plus 2 into ddx of x minus 4 minus x minus 4 into ddx of root x plus 2 upon root x plus 2 bracket square. Now the differentiation of the derivative of the x with respect to x is 1, derivative of constant is 0, and next is x minus 4 into ddx of root of x. The derivative of root of x is 1 upon 2 root x and derivative of constant is 0. And therefore next it's a bracket square. Still I am forgetting that. I will show you again. It's a bracket square. Now simplification, that is a root x plus 2 into 1, that is a root x plus 2 minus x minus 4 upon 2 root x. Now simplification, that is a root x plus 2 into 2 root x minus in bracket x minus 4 upon root x plus 2 bracket square into 2 root x. And here after simplification you will get 2 root x into root x plus 2 root x into, see this again, upon 2 root x plus 2 bracket square, that is a 2x plus 4 root x minus x plus 4, root x into root x is x, 2 into 2 4 root x minus x plus 4. Therefore x plus 4 root x plus 4 upon 2 root x into in bracket root x plus 2 bracket square. Now see this term. X means what? Root x bracket square. Therefore this is the perfect square of root x plus 2 bracket square. And these two terms will get cancelled, numerator and the denominator. These two terms will get cancelled, and then you will get the final answer is 1 upon 2 root x. And hence option C is the correct. Second, there may be the different answer in the textbook. Next is, if y is equals to ax plus b upon cx plus d, then find dy by dx. Again, here we will apply the quotient rule. These are the options. We'll find out the derivative with respect to the, by using the quotient rule, that is y is equals to ax plus b upon cx plus d. Differentiation with respect to x, dy by dx is equals to cx plus d into ddx of ax plus b. minus ax plus b into ddx of cx plus d upon cx plus d bracket square. Now the derivative of ax plus b, derivative of ax, the derivative of x is 1. 1 into a, that is a, and derivative of b, which is a constant, it's a derivative 0. What about the next? Cx plus d, the derivative of x is 1, c, and derivative of d is 0. Therefore, you will get that is cx plus d into a minus ax plus b into c upon cx plus d bracket square. That is a in bracket cx plus d minus c in bracket ax plus b upon cx plus d bracket square. Therefore, you will get acx plus ad minus acx minus bc, and the terms will get cancelled, and then you will get ad minus bc upon cx plus d bracket square. This is the dy by dx ax ad minus bc upon cx plus d bracket square. Now I will show these two problems by sequentially. Now y is equals to x minus 4 upon in root of x plus 2, then dy by dx is equals to. These are the options. Y is equals to x minus 4 upon in root of x plus 2. Y is equals to u upon v. Apply the quotient rule. That is dy by dx is equals to v into du by dx minus u into dv by dx upon v square. Therefore, y is equals to x minus 4 upon in root of x plus 2. Differentiation. Differentiate with respect to x, that is dy by dx. This is the v into du by dx minus u into dv by dx. Again, the derivative of x is 1. Keep this term as it is. Derivative of constant is 0. X minus 4 as it is. Derivative of root of x is 1 upon 2 root x. Derivative of 2 is 0 upon root x plus 2 bracket square. Now, the simplification. Root x plus 2 minus x minus 4 upon 2 root x. Now, this 2 root x will multiply here. That is the root x plus 2 into 2 root x minus in bracket x minus 4 upon 2 root x into root x plus 2 bracket square. Now, this 2 root x into root x, what will happen? That is a 2x. Again, 2 into 2 root x, that will become 4 root x, and minus x plus 4. Therefore, you will get 2x minus x. It will become x, 4 root x plus 4. Now, this is the perfect square. Root x plus 2 bracket square upon 2 root x plus 2 bracket square. Therefore, you will get 1 upon 2 root x, and hence option C is the correct one. Now, the next is if y is equals to ax plus b upon cx plus d, then dy by dx is equals to. These are the options. Y is equals to cx plus b upon ax plus b upon cx plus d. Then again apply the quotient rule. That is a v into, what is the v here? Cx plus d into derivative of u. What is u? Ax plus b. Therefore, cx plus d into ddx of ax plus b minus u. This is the ax plus b into ddx of cx plus d upon cx plus d bracket square. Now, the derivative of ax is 1. 1 into a. Derivative of b is 0 minus ax plus b into derivative of cx plus d. Derivative of d is 0. X, derivative of x is 1. 1 into c. And their simplification. That is a into cx plus d minus c into ax plus b upon cx plus d bracket square. Now, next is acx plus ad minus acx minus bc. Now, these two terms get cancelled, and hence dy by dx is equals to ad minus bc upon cx plus d bracket square, and hence option D is the correct one. Now, the next is third. If y is equals to 3x plus 5 upon 4x plus 5, then find dy by dx. Again, these are the options. Again, we will apply here the quotient rule. Now, see this here. Y is equals to 3x plus 5 upon 4x plus 5. Differentiate with respect to x. Dy by dx is equals to 4x plus 5. This is the v into du by dx minus u into dv by dx upon p square. Now the derivatives, derivative of the 3x is 3, derivative of 5 is 0, derivative of 4x is 4 because derivative of x is 1 and derivative of constant is 0 upon 4x plus 5 bracket square. Normal simplification is there. 4x plus 5 into 3 minus 3x plus 5 into 4, 4x plus 5 bracket square, their multiplication. Normal simplification is there, and therefore you will get minus 5 upon 4x plus 5 bracket square. Therefore dy by dx, that is option C, is the correct one. Now see this again. If y is equals to 3x plus 5 upon 4x plus 5, then dy by dx is equals to, these are the options. Y is equals to 3x plus 5 upon 4x plus 5, differentiate with respect to x. dy by dx is equals to, in bracket, 4x plus 5 into ddx of 3x plus 5 minus 3x plus 5 into ddx of 4x plus 5 upon 4x plus 5 bracket square. The differentiation. Derivative of 3x plus 5 is 3, derivative of x is 1, and derivative of 5 is 0. 3x plus 5, derivative of 4x plus 5, derivative of 5 is 0, and the derivative of 4x, derivative of x is 1, 1 into 4, that is 4, and normal multiplication and the simplification, multiplied this bracket with 3, this bracket with 4, then you will get 12x plus 15 minus 12x minus 20, and that is nothing but minus 5 upon 4x plus 5 bracket square, and hence option C is the correct one. Let's see the next one. Fourth one. If y is equals to 5 sin x minus 2 upon 4 sin x plus 3. Now here we are taking the trigonometric function and quotient rule for, then find the dy by dx. These are the options. Now y is equals to 5 sin x minus 2, 4 sin x plus 3. Now differentiate with respect to x. Dy by dx is equals to 4 sin x plus 3 into ddx of 5 sin x minus 2 minus, in bracket, 5 sin x minus 2 into ddx of 4 sin x plus 3 upon b square, that is a 4 sin x plus 3 bracket square. Now the derivative of sin x is cos x, therefore it is a 5 cos x, and derivative of 2 is 0, minus 2 is 0. Let's see this here. 4 sin x, therefore it's a derivative. 4 is constant, and derivative of sin of x is a cos x, and derivative of 3, which is constant, is 0 upon 4 sin x plus 3 bracket square. Therefore 20, normal simplification is a 20 sin x into cos x plus 15 cos x minus 20 sin x into cos x plus 8 cos x upon 4 sin x plus 3 bracket square. Normal simplification is there. That is equals to 23 cos x upon 4 sin x plus 3 bracket square. Therefore the option B is a correct one. That is y is equals to 5 sin x minus 2 upon 4 sin x plus 3. Now apply here the quotient rule. Differentiate with respect to x. Dy by dx is equals to 4 sin x plus 3 into ddx of 5 sin x minus 2 minus 5 sin x minus 2 into derivative of 4 sin x plus 3 upon 4 sin x plus 3 bracket square. Now the derivative of 5 sin x minus 2. The derivative of 5 sin x, derivative of sin x is cos x, therefore it is a 5 cos x, derivative of 2 is 0, minus 5 sin x minus 2, and derivative of 4 sin x, which is the 4 cos x, derivative of 3 is 0, upon 4 sin x plus 3 bracket square. Normal multiplication is there, that is a 20 sin x into cos x, 5 cos x into 3, that is a 15. Similar multiplication is there. Minus 20 sin x into cos x plus 8 cos x, these two terms get cancelled, and that is you will get 23 cos x upon 4 sin x plus 3 bracket square, and hence option B is a correct. Suppose f of x is derivative of g of x and g of x is derivative of h of x. Now here h of x is a sin x plus b cos x plus c. Then find f of x plus h of x. These are the options. Now see this, f of x is the derivative of g of x and g of x is the derivative of h of x. Means what we have h of x. If you find out it's a derivative, then you will get g of x. If you find the derivative of g of x, you will get f of x. And add these two terms. Now see this here. H of x is equals to a sin x plus b cos x plus c. H dash of x is equals to a cos x minus b sin x, and derivative of c is 0. This is nothing but the g of x. That is, the g of x is equals to a cos x minus b sin x. F of x is equals to g dash of x. Again differentiate that g of x. Minus a sin x minus b cos x. Take the minus sign common. Then you will get f of x is equals to minus a sin x plus b cos x. Therefore, f of x is equals to minus in bracket a sin x plus b cos x, and addition of these two terms, that is minus in bracket a sin x plus b cos x, a sin x plus b cos x plus c, and you will get the answer is C. Plus minus get cancelled. Hence option B is a correct one. Now see again I will repeat this problem. Suppose f of x is the derivative of g of x and g of x is the derivative of h of x. H of x is a sin x plus b cos x plus c. Then find f of x plus h of x. Now this is the h of x. It's a differentiation. Is nothing but the g of x. Therefore we will differentiate h of x with respect to x. A is multiplicative constant. Derivative of sin of x is the cos of x. Derivative of cos of x is a minus sin x. B is a multiplicative constant and derivative of constant c is a 0. Therefore a cos x minus b sin x. This is our g of x. Now again f of x is nothing but the derivative of g of x. Therefore we will find out the derivative of g of x. Now g of x is a cos x minus b sin x. Now differentiate this. What is the derivative of cos of x? Which is a minus sin x, and derivative of sin of x is a cos of x. Take minus sign as a common, then you will get f of x is equals to minus in bracket a sin x plus b cos x. Now therefore f of x plus h of x minus in bracket a sin x plus b cos x plus a sin x plus b cos x plus c, and overall you will get the c. Hence option B is a correct one. Now the next is C. F of x is equals to 2x plus 6 for x lies between 0 to 2. F of x is equals to ax square plus bx for x lies between 2 to 4. Is a differentiable at x is equals to 2. Then find the value of a and b. Now at x is equals to 2. Now see this here. The function breaks here at the point 2. The given function breaks at the point 2, and we want to find out, as it is a differentiable at x is equals to 2. That is to find out the right hand side limit. That is a 2 plus. Then we take this function because x is a greater than 2. And to find out the left hand side differentiation, that is it is a 2x plus 6. Now see this here. Limit x tends to 2 plus f of x. Had applied the definition of the continuity. Therefore, this is the next is left hand side differentiation. And therefore, you will get the value. That is 4a plus 2b is equals to 10. ax square plus bx f of 4, which is these are the values. I had decided. And what will be the options for that? The value of a is minus 3 by 2 and the value of b is 8. Now here f of x is equals to 2x plus 6, where x lies between 0 to 2. And f of x is equals to ax square plus bx for x lies between 2 to 4 is differentiable at x is equals to 2. In this case, I had solved this problem in another method. That is, at x is equals to 2, left hand side limit and right hand side limit. For the right hand side limit, I get the 4a plus 2b and the value of the function at x is equals to 4. Left hand side limit, that is 2x plus 6. Orally, that is, I am getting the 10. That is a 4a plus 2b is equals to 10. 2a plus b is equals to 5. And I find out the options. Which options would be suit here for this? Which values are required to satisfy this equation? That is a 2a plus b is equals to 5. Therefore, the values of a is minus 3 by 2 and value of b is 8. By using this, I have decided the value of a is minus 3 by 2 and b is 8. A is minus 3 by 2, b is 8. Now the 7th. If f of x is equals to x square plus sin x plus 1 for x is less than or equal to 0, f of x is equals to x square minus 2x plus 1 for x is greater than 0, then f is a continuous at x is equals to 0 but not differentiable at x is equals to 0. Second option is f is neither continuous nor differentiable at x is equals to 0. Third, f is not continuous at x is equals to 0 but differentiable at x is equals to 0. And the D, f is both continuous and differentiable at x is equals to 0. The first is f is continuous at x is equals to 0 but not differentiable at x is equals to 0. This option is the correct one. Now in this case, if you find out as the given function is a continuous, we find out the left hand side limit, the value of the limit is 1. The right hand side limit, the value of the limit is 1. The value of the function is also 1. Therefore, this function is continuous. But it is not differentiable. How it is? If you find out the left hand side differentiation, then you will get its a value is a minus, its a value is a 1. If you find out the right hand side differentiation, it is a minus 2. Both are not equal. Left hand side derivative is not equals to the right hand side derivative. And hence, the function is not differentiable. Therefore, out of this option, f is a continuous at x is equals to 0, but not differentiable at x is equals to 0. If f of x is equals to x raised to 50 upon 50, x raised to 49 upon 49, x raised to 48 upon 48 plus dash dash x square upon 2 plus x plus 1. Then f dash of 1 is very simple. Is that the values? We find out its a derivative. That is f dash of x is equals to 50 x raised to 49 upon 50. 49 upon 49. And in this way, we can find out their derivatives. See this here. 49 upon 49. 48 upon 49 x raised to and 2x upon 2 plus 1. Therefore, x raised to 49, 48, 47 plus x plus f dash of x. Therefore, f dash of 1 is 1 plus 1 plus 1. Okay. These are the, that is equals to 50. Therefore, f dash of 1 is, now again you can see this from here. Find out the derivatives. If we add this, all are the 50 terms. Therefore, option C is the correct one. Now the question number 2. Determine whether following functions is differentiable at x is equals to 3, where the function f of x is equals to x square plus 2 for x is greater than or equal to 3, and 6x minus 7 for x is less than 3. We'll find out the LDH and RDH, that is a left hand side differentiation and the right hand side differentiation. Left hand side differentiation, which is left hand side differentiation, that is f of 3 plus h minus f of 3 upon h. Now the next is right hand side differentiation. We'll take the next function and simplify only. Square it, minus 11, limit tends to 0, and take h as common, then you will get 6. Therefore, right hand side differentiation is equals to the left hand side differentiation, that is equals to 6, and therefore the given function is a differentiable. We'll see this again. Determine whether the given function is differentiable. F of x is equals to x square plus 2 for x is greater than or equal to 3, and f of x is equals to, it's a value, that is equals to f of 3 is a 11. Therefore, left hand side differentiation, we find out the value of the function. Therefore, by using the definition, left hand side differentiation, limit h tends to 0, that is f of 3 plus h minus f of 3 upon h, and for that we take the function, that is a 6x minus 7 because x is less than 3. Substitute the values. Therefore, limit h tends to 0, 6x upon h get cancelled. It's a 6 one. Now the right hand side differentiation, that is the limit h tends to 0 plus f of 3 plus h minus f of 3 upon h, and therefore h tends to 0, that is 3 plus h bracket square plus 2 minus 11 upon h. If we expand this, then 9 plus 6s plus h square plus 2 minus 11, and if you take h as common, then you will get its value 6. Both are equal. Therefore, f is a differentiable at x is equals to 3 and f dash of 3 is equals to 6. Now the question number 2. Find the values of P and Q that make the function f of x differentiable everywhere on capital R. Now f of x is equals to 3 minus x for x is less than 1 and equals to px square plus qx for x is greater than or equal to 1. F is a differentiable on capital R and hence is a differentiable at x is equals to 1. Therefore, left hand side differentiation is equals to the right hand side differentiation at x is equals to 1. Now we'll find out their differentiation. F of x is equals to px square plus qx for x is a greater than or equal to 1. The value of f of 1, that is x is replaced by 1, then you will get p into 1 square plus q into 1, that is a p plus q. And therefore, left hand side differentiation, that is a limit h tends to 0, f of 1 plus h minus f of 1 upon h. Therefore, here we take the function that is a 3 minus in bracket 1 plus h. Now the limit h tends to 0, 3 minus in bracket 1 plus h minus p plus in bracket p plus q upon h. Limit h tends to 0, 2 minus h minus p minus q upon h. Let's say the exist. We must have that is a 2 minus p minus q is equals to 0. And hence p plus q is equals to 2. Therefore, that is a minus 1. Now right hand side differentiation, limit h tends to 0, f of 1 plus h minus f of 1 upon h, p in bracket 1 plus h bracket square plus q in bracket 1 plus h minus p plus q upon h tends to 0, and their simplification, limit h tends to 0, 2ph plus ph square plus qh upon h, limit h tends to 0. Therefore, 2p plus q as h tends to 0, 2p plus q, that is equals to minus 1. Substitute the value of q, therefore you will get p is equals to minus 3. P plus q is equals to 2, therefore you will get q is equals to 5. Hence, p is minus 3 and q is equals to 5. Now let's see again. This is the find the value of p and q that makes the function f of x differentiable everywhere on capital R. F of x is equals to 3 minus x for x is less than 1. And f of x is equals to px square plus q x for x is greater than or equal to 1. F is a differentiable on R. Hence, it is a differentiable at x is equals to 1. R is the set of the real number. It contains 1. Therefore, it's definitely that it is a differentiable at x is equals to 1. As it is a differentiable, left-hand side differentiation at x is equals to 1 is equals to the right-hand side differentiation at x is equals to 1. Now see this. F of x is equals to px square plus qx for x is greater than or equal to 1. Now, what is the value of the given function at x is equals to 1? That f of 1 is equals to 1. P in bracket 1 square plus q in bracket 1 and which is equals to p plus q. Here, the left hand side differentiation f dash of L of f dash of 1 that is equals to left hand side differentiation. We take the function p minus x. Therefore, L of f dash of 1 is equals to limit h tends to 0, f of 1 plus h minus f of 1 upon h. For that, what is the value of f of 1 plus h? Now for the left hand side, we take the function 3 minus x. That is a 3 minus in bracket 1 plus h and the value of f of 1. What is the value of f of 1? Is a p plus q. Substitute here. Simplify here. Then you will get 2, 3 minus 1. That will become 2 minus h minus p minus q. That is a 2 minus p minus q minus h upon h. That is L of f dash exists. When this will be exist, that is the value of, that is a 2 minus p minus q. That must be 0. When it will be the 0, that is a 2 minus p minus q is equals to 0. That is a p plus q is equals to 2. Therefore, this is the first equation. And therefore, next is that is equals to left hand side limit. In left hand side differentiation, limit h tends to 0 minus h upon h. We have substituted the value of this is 0. Therefore, it is a minus h upon h. And left hand side differentiation is equals to minus 1. Now we'll see the right hand side differentiation. For that, we take the function. That is we take the function px square plus qx. Now see this again here. Limit h tends to 0, f of 1 plus h minus f of 1. That is the limit h tends to 0, px square plus qx. That is the p in bracket 1 plus h bracket square plus q in bracket 1 plus h minus p plus q upon h. Now simplify this. 1 plus h bracket square means what? 1 plus 2h plus h square. Multiplied it with p, then you will get p plus 2ph plus ph square. Now this is a q and the qh minus p minus q. Simplify it. Take the common, h as a common. Then you will get, as h tends to 0, you will get 2p plus q. Now the 2p plus q, that is equals to minus 1. Because the left hand side differentiation is equals to the right hand side differentiation. Therefore, the value of 2p plus q is equals to minus 1. And therefore, 2p, the value of the q is 2 minus p from the previous one, that is equals to minus 1. And if we simplify this, that is a 2p minus p. This is a p plus 2 is equals to minus 1 and the value of p is equals to minus 3. Again, that is the p plus q is equals to 2. Substitute the value of p. Then you will get, that is the q is equals to 5. And before that, let's see this again. We have p plus q that is equals to 2, and by using that, p plus q is equals to 2, therefore q is replaced by 2 minus p, and simplify this, p is equals to minus 3 and q is equals to 5. That is a, hence p is equals to minus 3 and q is equals to 5. Now the third, determine the values of p and q that make the function f of x differentiable on capital R, where f of x is equals to px cube for x is less than 2 is equals to x square plus q for x is greater than or equal to 2. Now again same thing is here. F is a differentiable on the capital R, then it must be differentiable at x is equals to 2. Therefore, left hand side differentiation, that is L of f dash of 2 is equals to R of f dash of 2. F of x is equals to x square plus q for x is greater than or equal to 2. F of 2 is, that is 4 plus q. L of f dash of 2, that is we take the left hand side differentiation. Limit h tends to 0, f of 2 plus h minus f of 2. That is a p in bracket 2 plus h bracket cube minus f of 2. The value of f of 2 is a 4 plus q upon h. Expand this, p 2 plus h bracket cube, h cube plus 6h square plus 12h plus 8 minus 4 plus q upon h. Now see this here. That is from these terms, that is a h cube 6h square plus 12h. We take h as common. And what is the next? P into 8. That is 8p minus 4 and minus q in the next remaining bracket. Next. Left hand side differentiation at x is equals to 2 exists. We must have, that is a 8p minus 4 minus q is equals to 0. Therefore, 8p minus q is equals to 4. Therefore, L of f dash of 2, that is a ph plus h square plus 6h plus 12. The value we have substituted, it is 0. That is a, if you take, that is a multiplied this h with, that is this h get cancelled. Then you will get limit h tends to 0, p in bracket h square plus 6h plus 12 as h tends to 0. Therefore, you will get 12p for the left hand side differentiation. Now the right hand side differentiation, that is r of f dash of 2 is equals to limit h tends to 0, f of 2 plus h minus f of 2 upon h. Now see this again, limit h tends to 0. That is a 2 plus h bracket square plus q minus 4 plus q, the value of the f of 2, we have found out it. The given function is x square plus q for x is greater than 2. That is a 4 plus 4h plus h square plus q minus 4 minus q. And plus q minus q get cancelled, plus 4 minus 4 get cancelled. Take h as common. Therefore, you will get 4 plus h upon h is 0. That is 4. Therefore, 12p is equals to 4, p is equals to 4 upon 12, that is p is equals to 1 upon 3. Now substitute the value of p in 8p minus q is equals to 4. Then you will get the value of the q. Therefore, q is equals to minus 4 upon 3. Hence, p is equals to 1 upon 3 and q is equals to minus 4 upon 3. Now we'll see this here. This is a differentiable on R. Therefore, it must be differentiable at x is equals to 2. We'll find out the left hand side limit and right hand side limit. Before that, we'll find out the value of the function at x is equals to 2. For that, we take the function q square, x square plus q, that is 4 plus q, left hand side differentiation. For that, we take the function pxq. This is the value of f of 2, their expansion. Now for that, f dash of 2 must exist. For that, the value of this term must be 0. Therefore, we take 8p minus 4 minus q is equals to 0. Therefore, 8p minus q is equals to 4. Therefore, L of f dash, that is a ph in bracket h square plus 6h plus 12 upon h. H get cancelled. Limit h tends to 0. Then p in bracket h square plus 6h plus 12. Therefore, you will get p in bracket 0 plus 0 plus 12, that is a 12p. Now, the right hand side differentiation, r of f dash of 2, limit h tends to 0, f of 2 plus h minus f of 2. Again 2 plus h, bracket square plus q minus 4 plus q. Here we take the function x square plus q for x is greater than or equal to 2. Expand it, simplify it, take h as common, these get cancelled. Limit h tends to 0, 4 plus h, that is equals to 4. Therefore, 12p is equals to 4. Left hand side differentiation is equals to the right hand side differentiation. We get the 12p, and the right hand side differentiation we get the value as a 4. Therefore, p is equals to 4 upon 12, that is equals to 1 upon 3. Now substitute the value of this p, that is 8p minus q is equals to 4. Problems are up to some extent they are descriptive. Therefore, you have to remember this, how they are solved. You have to do the practice number of the time, then you can solve it. That is 8 into 1 upon 3 minus q is equals to 4. The value of q is equals to minus 4 upon 3. Therefore, p is 1 by 3, q is minus 4 upon 3. Now the fourth one, determine all real values of p and q that ensures the function f of x is equals to px plus q for x is less than 1, and tan of pi x upon 4 for x lies between 1 and 2 is a differentiable at x is equals to 1. Now f is a differentiable at x is equals to 1. Therefore, left hand side differentiation is equals to the right hand side differentiation. F of x is equals to px plus q for x is less than or equal to 1. F of 1 is equals to px, that is p plus q, substitute x is equals to 1. Left hand side differentiable, L of f dash of 1, that is the limit h tends to 0, f of 1 plus h minus f of 1 upon h. H tends to 0, that is 1 p in bracket 1 plus h plus q minus in bracket p plus q upon h. Because f of x is p plus q for x is less than or equal to 1. Therefore, after simplification, you will get q to get cancelled, h upon h, ph upon h, that is a h, ph upon h. Therefore, that get cancelled, the limit is p. Now next is the right hand side differentiation, r f dash of 1 is equals to limit h tends to 0, f of 1 plus h minus f of 1 upon h. Therefore, tan of x, that is a pi in bracket 1 plus h upon 4 minus p plus q. The value of f of 1 is a p plus q. R of f dash of 1 exists, so we must have, that is a p plus q is equals to 0. P plus q is equals to 1. Therefore, limit minus 1. One means what? Tan of pi by 4. Therefore, tan of pi by 4 plus pi h upon 4 minus tan of pi by. Here we are using one more result. The result is that, see this result, tan of a minus tan of b is equals to tan of a minus b in bracket 1 plus tan a into tan b. Therefore, limit h tends to 0. Tan of pi h upon 4 upon pi h upon 4 in bracket 1 plus tan of pi h pi by 4 plus pi h upon 4 into tan of pi by 4 into pi by 4. this is the pi by 4. Limit h tends to 0. Tan of pi h upon 4 upon pi h upon 4. The value of this limit is 1. Limit h tends to 0. 1 plus tan of pi by 4 plus pi h upon 4 into tan of pi by 4. And the value of this limit is 1. H tends to 0. 1 plus tan of pi by 4 into pi by 4. Tan of pi by 4 is 1. 1 into 1, that is a 2. It's very big and complicated problem. If you see the number of the time, then you will get that is 1 plus 1, that is a 2, which is equals to pi by 2. Therefore, p is equals to pi by 2. Substituting this value of p in 2, then you will get pi by 4 plus q is equals to 1. Therefore, q is equals to 1 minus pi by 2. And that is p is pi by 2 and q is a 2 minus pi upon 2. Now we'll see again the same problem, because it is a very big one. Continuity at x is equals to, that is the differentiability at x is equals to 1. Left hand side differentiation is equals to the right hand side differentiation. F of x is equals to px plus q. For x is less than or equal to 1, f of 1 value p plus q. Left hand side differentiation, for that we take the function px plus q. Substitute the value f of 1 plus h is p in bracket 1 plus h plus q minus p plus q upon h. Simplify it. You will get left hand side differentiation is a p. Next is the right hand side differentiation. H tends to 0. F of 1 plus h minus f of 1 upon h. That's the tan of pi in bracket 1 plus h upon 4 minus the value p plus q upon h. R of f dash of f must be exist. That is, we must have the value of p plus q, that is equals to 1. Therefore, p plus q must be 1. Now see this here. 1 means what? Tan of pi by 4. Now here is one more important formula, is a tan a minus tan b is equals to tan of a minus b into 1 plus tan a into tan b. Now what is here? This is the a and this is the b. Therefore, tan a minus tan b, that is equals to tan of a minus b. Now what is here? A, tan of pi by 4 plus pi h upon 4 minus pi by 4 into 1 plus tan a into tan b. That is the tan of pi by 4 plus pi h upon 4 into tan of pi by 4. Therefore, pi by 4 get cancelled. That is, limit h tends to 0. Tan of pi h upon 4 upon pi h upon 4. Simplify this. That is, we are adjusting here pi by 4. Yeah. Limit of this is 1. And limit of this is tan of pi by 4 into tan of pi by 4. And therefore, you will get pi by 4. This pi by 4 is here. And the limit of this and limit of this are here. The limit h tends to 0. Tan of pi h upon 4 upon pi h upon 4 is 1. There is 1. Now in bracket 1, as h tends to 0, this becomes 0. Tan of pi by 4 plus 0 into tan of pi by 4. Now what's happening here? It is a pi by 4. 1 plus 1 into 1. 1 into 1 means 1. That is 1 plus 1 is 2. That is pi by 4 into 2, which is equals to pi by 2. And therefore, but we have the left hand side differentiation, that is a p, and right hand side differentiation, if we simplify it, then we are getting See this here. In left hand side differentiation we get the p, and here right hand side differentiation we get the pi by 2, and therefore left is equals to the right, their differentiation. Therefore p is equals to pi by 4, pi by 2, and substitute this value, that is the p plus q is equals to 1, and its value is q is equals to 1 minus pi by 2, that is nothing but the 2 minus pi upon 2, and hence these are the values of p and q. All the problems are tough one, they are highly descriptive. Therefore, to remember these, see the number of the times, then you will get the total idea. Now the problem number 5. Discuss whether the function f of x is equals to mod of x plus 1 plus mod of x minus 1 is differentiable for every x belongs to set of real number. Now here f of x is equals to mod of x plus 1 plus mod of x minus 1 if x is positive. Then mod of x minus 1 is equals to x minus 1, and mod of x plus 1 is equals to x plus 1. And if x is negative, then mod of x minus 1 is a minus in bracket x minus 1, then you will get 1 minus x. And next is mod of x plus 1 is equals to minus x and minus 1. That is when x is a negative, then you will get mod of x plus 1 is equals to x plus 1. Both the time this mod is same. Therefore, f of x is equals to x plus 1 plus 1 minus x, and that is equals to 2 for x is less than 1. And f of x is equals to x plus 1 plus x minus 1 for x is a greater than, that is equals to 2x for x is a greater than or equal to 1. Therefore, now f of 1, the value of f of 1, that is a 2 into 1, that is equals to 2. Now left hand side differentiation at x is equals to 1, that is limit h tends to 0, f of 1 plus h minus f of 1 upon h, that is a 2 minus 2 upon h, and its a value is f of 2, that is equals to 0. Now the right hand side differentiation at x is equals to 1, limit h tends to 0, f of 1 plus h minus f of 1 upon h, that is equals to 2 in bracket 1 plus h minus f of 2 upon h. Therefore, you will get 2. Therefore, both are not equal. Right hand side differentiation at x is equals to 1 is not equals to left hand side differentiation at x is equals to 1, and hence f is not differentiable at x is equals to 1. Similarly, it can be proved that f is not differentiable at x is equals to minus 1, and hence f is not differentiable for every x capital. See this again. F of x 1 plus x plus mod of x minus 1 is differentiable at x is equals to, for every x belongs to capital R, the function we are taking at x is equals to 1, x is greater than 1, and x is less than 1, f of x, x is less than 1, then you will get 2, for x is greater than or equal to 2, then f of x is equals to 2x, it's a value, f of 1 is 2 into 1, that is equals to 2, left hand side differentiation, that is f of 1 plus h, the value of f of 1 is 2, f of 1 plus h, that is a 2 minus 2, 1 plus h is 2, minus 2, f of 1 is 2, and 1 plus h is also 2. It's a constant function. 2 minus 2, it's a left hand side differentiation is 0. Right hand side differentiation, for the right hand side differentiation we take the function 2x, that is a f of 1 plus h minus f of 1, that is a 2 in bracket 1 plus h minus 2, 2h upon 2, that is you will get the 2. Now here is a right hand side differentiation is 2, left hand side is 0, both are not equal, and hence the given function is not differentiable at x is equals to 1. Similarly, we can prove that it is not differentiable at x is equals to minus 1, and hence f is not differentiable at x is equals to, for every x belongs to set of real number. Now next, number 6, test whether all the problems are too much complicated. You practice more and more. F of x is equals to 2x minus 3 for x is greater than or equal to 2. F of x is equals to x minus 1 for x is less than 1. Is a differentiable at x is equals to 2. The same thing is here. We first find out the value. F of x is equals to 2x minus 3 for x is greater than or equal to 2. Therefore, f of 2 is 4 minus 3, that is equals to 1. Now, right hand side differentiation, that is r of f dash of 2 is equals to limit h tends to 0, f of 2 plus h minus f of 2 upon h. H tends to 0, f of 2 in bracket 2 plus h minus f of 3, minus 3, and the value of f of 2 is minus 1. Therefore, let simplification, limit h tends to 0, 4 plus 2h minus 3 minus 1. Therefore, you will get 2h upon h, that is equals to 2. Therefore, its value is 2. Now, left hand side differentiation, that is the limit h tends to 0, f of 2 plus h minus f of 2 upon h, limit h tends to 0, that is the 2 plus h minus 1, simplify it, then you will get 1. 2 plus h minus 2, therefore its limit is 1. Now we are left hand side differentiation at x is equals to 2 is not equals to right hand side differentiation at x is equals to 2. And hence f is not differentiable at x is equals to 2. Now see this again. Test whether the function f of x is equals to 2x minus 3 for x is greater than or equal to 2. For x is less than 2 is differentiable at x is equals to 2. F of x is equals to 2x minus 3 for x is greater than or equal to 2. The value of f of 2 is 1. The right hand side differentiation, we take the function 2x minus 3 f of 2 plus h minus f of 2, that is a 2 in bracket 2 plus h minus 3 minus 1. The value of f of 2 is 1. That is a 4 plus 2h minus 3 minus 1. Therefore, you will get 2h upon h, and the limit is 2 for the right hand side differentiation. Left hand side differentiation, L of f dash of 2 is equals to f of 2 plus h minus f of 2 upon h. That is f of 2 plus h minus 1 minus 1. Their simplification, h upon h as h tends to 0, which is equals to 1. Therefore, r of f dash of 2 is not equals to L of f dash of 2 at x is equals to 1. Therefore, it is not differentiable at x is equals to 2. It's very simple. But still you have to do more practice and practice. Now the next is problem number 7. Test whether the function f of x is equals to x square plus 1 for x is greater than or equal to 2x plus 1 for x is less than 2. Now we'll find out the value of f of x at x is equals to 2. We'll take the function x square plus 1. Therefore f of 2 is 2 square plus 1, that is equals to 5. 4 plus 1, 5. Now left hand side differentiation, L of f dash of 2, limit the value of the function at x is equals to 2 is 2 square plus 1, that is equals to 5. Therefore the left hand side differentiation, that is L of f dash of 2, is equals to limit h tends to 0 f of 2 plus h minus f of 2 upon h. Substitute the values. That is for the left hand side, the function is 2x plus 1, that is a 2 in bracket 2 plus h tends to 0, 2h upon h, therefore you will get the limit is 2. Left hand side differentiation is 2. Now the right hand side differentiation, limit h tends to 0, f of 2 plus h minus f of 2 upon h, that is a 2 plus h bracket square plus 1 minus 5 upon h, limit h tends to 0. The function is f of x is equals to x square plus 1 for x is greater than or equal to 2. 4 plus 4h plus h square plus 1 minus 5 upon h, limit h tends to 0. Therefore you will get 4h plus h square upon h. Take h as common, then you will get 4 in bracket 4 plus h upon h. Limit is 4h tends to 0. Therefore left hand side differentiation is not equals to the right hand side differentiation. Therefore f is not a differentiable at x is equals to 2. Now see again. Test whether the function f of x is equals to x square plus 1 for x is greater than or equal to 2. 2x plus 1 for x is less than 2. F of x is equals to x square plus 1 for x is greater than or equal to 2. We will find out the value f of 2 is 2 square plus 1, that is equals to 4 plus 1 is equals to 5. Left hand side differentiation, L of f dash of 2 is equals to limit h tends to 0 f of 2 plus h minus f of 2. Here we take the function 2x plus 1. That is a 2 in bracket 2 plus h plus 1 minus 5. Simplify it. You will get 2h upon h, that is equals to 2. Now the right hand side differentiation, r of f dash of 2, limit h tends to 0, f of 2 plus h minus f of 2 upon h. The function is x square plus 1, that is a 2 plus h bracket square plus 1 minus 5. Simplify it, take h as common, then h tends to 0. H in bracket 4 plus h upon h get cancelled. Therefore the limit is 4. Both are not equal because the left hand side differentiation is not equals to 2 and here is a 4. Both are not equal, therefore f is not differentiable at x is equals to 2. Test whether the function, now next problem number 8. Test whether the function f of x is equals to 5x minus 3x square for x is greater than or equal to 1. 3 minus x for x is less than 1 is differentiable at x is equals to 1. F of x is equals to 5x minus 3x square for x is greater than or equal to 1. That's a value at x is equals to 1 is 2. F of 1 is 2. Now r of f dash of 1, that is a right hand side differentiation at x is equals to 1, limit h tends to 0, f of 1 plus h minus f of 1 upon h tends to 0. 5 in bracket 1 plus h minus 3 in bracket 1 plus h bracket square minus 2. Now their simplification, h tends to 0. 5 plus 5h minus 3 in bracket 1 plus 2h plus h square minus 2. H tends to 0. 5 plus 5h minus 3 minus 6h minus 3h square minus 2 upon h. If you cancel it, then as h tends to 0, minus h minus 3h square upon h. Now take minus h as common, then in bracket 1 plus 3h upon h will cancel, and taking the limit you will get as h tends to 0, but here is a minus sign, therefore the limit is minus 1, and hence now the left hand side differentiation, it was the right hand side differentiation. Limit h tends to 0, f of 1 plus h minus f of 1 upon h, that is a 3, minus in bracket 1 plus h minus 2 upon h, simplify it, that is 3 minus 1 minus h minus 2 upon h, that is equals to minus 1. Now here both are equal. Left hand side differentiation is a minus 1 from 1 and 2. R of f dash of 1 is equals to L of f dash of 1, and therefore f is a differentiable at x is equals to 1. See this again. Test whether the function f of x is equals to 5x minus 3x square for x is greater than or equal to 1. 3 minus x for x is less than 1, differentiable at x is equals to 1. F of x, find the value of f of x at x is equals to 1. For that, we take the function 5x minus 3x square, its value is 2. R of f dash of 1, limit h tends to 0, f of 1 plus h minus f of 1 upon h. Substitute the value, that is 5 in bracket 1 plus h minus 3 in bracket 1 plus h bracket square minus 2. For the right, we take the function 5x minus 3x square. And the next is, that is minus h minus 3h square upon h. Take minus h common, h tends to 0, you will get minus 1. L of f dash of 1, h tends to 0, f of 1 plus h minus f of 1. 3, for that we will take the function 3 minus x for x is less than 1. And after simplification, you will get the minus 1. Now in this case, left hand side differentiation is equal to the right hand side differentiation. Hence, the given function is a differentiable at x is equals to 1. Now the problem number 9. If f of 2 is 4, f dash of 2 is 1, then find limit x tends to 2, x f of 2 minus 2 f of x upon x minus 2. Put x is equals to 2 plus h. As x tends to 2, h tends to 0. Limit x tends to 2, x f of 2 minus 2 f of x upon x minus 2. H tends to 0. The value of x is 2 plus h into f of 2 minus 2 in bracket f of 2 plus h upon h. Limit h tends to 0. H f of 2 plus 2 f of 2 minus 2 f of 2 plus h upon h. Limit h tends to 0. H f of 2 minus f of 2 plus h minus f of 2. So we are substituting the values. Now h f of 2 upon h and h f of 2 minus 2 times f of 2 plus h. From these two we take 2 as common, then in bracket you will get f of 2 plus h minus f of 2. That is h. Therefore limit h tends to 0. F of 2 limit 2 times h tends to 0, f of 2 plus h minus f of 2 upon h. That is equals to f of 2 minus 2 times f dash of 2. That is the value of f of 2 is 4 minus 2 f dash of 2 is 1. That is a 4 minus 2. that is equals to 2. Now we'll see the next, the same problem. If f of 2 is 4, f dash of 2 is 1, then limit x tends to 2, x f of 2 minus 2 f of x upon x minus 2. Put x is equals to 2 plus h, then as x tends to 2, h tends to 0. Also x minus 2 is h, limit x tends to 0, x tends to 2, x f of 2 minus 2 f of x upon x minus 2. Now substitute the value. Limit h tends to 0, x is replaced by 2 plus h into f of 2 minus 2 in bracket f of 2 plus h upon h. Now 2 h f of 2 plus 2 f of 2 minus 2 f of 2 plus h. Now here h f of 2 and bring these two terms together and take minus 2 as common. Then you will get f of 2 plus h minus f of 2 upon h. And simplify it. That is limit h tends to 0, h f of 2 upon h minus 2. F of 2 plus h minus f of 2 upon h. And therefore you will get f of 2 minus limit 2 times h tends to 0, f of 2 plus h minus f of 2 upon h. That is nothing but the 2 times f dash of 2. That is the f dash of 2. The value of the f dash of 2 is 1. Because we have given that the f of 2 is 4 and f dash of 2 is 1. That is 4 minus 2 into 1. That is equals to 2. And hence the answer is 2. Now the next problem. If y is equals to e raised to x upon root x, then find the dy by dx where x is equals to 1. Y is equals to e raised to x upon root x. Very simple problem. Apply the quotient rule. Dy by dx is equals to root x into derivative of e raised to x minus e raised to x into ddx of root x upon root of x bracket square. Root x is as it is, derivative of root of x, e raised to x is e raised to x, and next is e raised to x into derivative of root of x is 1 upon 2 root x upon x. Now simplify this. Take e raised to x common upon x, root x minus 1 upon 2 root x. Simplify 2 root x into root x minus 1 upon 2 root x. And their simplification, you will get 2x minus 1 upon 2 root x upon x, e raised to x upon x. Therefore, dy by dx is equals to e raised to x upon x in bracket 2x minus 1 upon 2 root x at x is equals to 1. X is replaced by 1, that is e upon 1. That is 2 into 1 minus 1 upon 2 root of 1. That is e 2 minus 1 upon 2. And that is nothing but the e by 2, and hence dy by dx at x is equals to 1 is e upon 2. And in this way, we have completed the miscellaneous exercise for the differentiation. The first part is too much tough, that is to find out the left hand side derivative, right hand side derivative. If they are equal, then the given function is a differentiable at x is equals to. Then the given function is a differentiable at x is equals to that particular point. For that, all the problems you have to remember very accurately. Do the practice more and more, then you can write in the examination very accurately. Now we'll see in the next video. Till then, goodbye.